So we are doing this over here, right?
It's
This
live
session
now.
stays in this group only, right?
No, it's actually going
Hello,
live.
or do I have to join it on the YouTube?
No, you can just say it, then it's going to be recorded. I will share you the video link. Okay. So we are live now.
Hello.
Okay. Yeah, we are live now. Wait. Hello guys, welcome to this introduction to Explore Machine Learning, the Explore ML session by Google AI, Developer Student Clubs, and the Google developers. Okay, so let me tell you some rules before getting started, and let me introduce you to our special guest, Nikhil Parikh from University of Texas Dallas. He'll be taking the session just after the rules
Hello.
and some introduction. He's right over here. Like he's here, he's joining us via the video call. You can see on your screens. Nikhil, you can wave.
Hi guys.
So I guess everyone's saying hi in the chat. You can say hi in the chat. You can see the chat. Okay, so
Okay, perfect.
as promised, this
So
session is.
Ayush, I haven't opened up the chat yet on the YouTube, but please feel free to stop me wherever you want to. And if someone posts a question, I'll be really happy to answer it then and there. So just don't worry about that.
Sure thing.
All right.
Maybe now you can see the chat, I guess.
Okay, let me just have a look. All right, or you can just send me the YouTube link on the chat box again, and I'll just open it up real quick.
Okay, so now I guess you can see the chat.
All right, or you can just send me the YouTube link on chat.
Okay.
I'm afraid I still can.
Okay, so let me introduce you to Nikhil Parikh from University of Texas Dallas. He's in India right now, just came like a few days ago, and he's the machine learning engineer in Texas Biomedical Device Center in the United States. So he'll be taking the session just after the introduction and some rules about the workshop. Then he can go ahead. So let me tell you the unique code that you got. Bad voice. Wait, let me. Is it good now? Am I clear? Wait.
Hello, can you hear me?
Yeah, I can hear you. Wait, let me.
All right.
Okay, yeah, audible. I'm audible, but maybe we'll check on the voice. It will be fixed in 5 minutes. So the unique entry code that you've got on your email will be used as your attendance, and we'll be sharing 2 forms, one at any random time in the chat. Then you have to fill your email and that unique entry code. It will be open for only 5 minutes. We'll be taking a break for 5 minutes in between. Okay, let me work on that.
Yeah, I can hear you.
Wait. Okay, let me tell you if my voice improved or not. Let me know, please, in the chat if I'm not Okay. Is it clear now? Okay, I'm getting yes. It's better now. So you will be getting two Google Forms. We'll be taking breaks for 5 minutes in between, two times, and it'll be at random time so that we'll be make sure that you are attending session like in full focus. So at any random time, we'll be sharing the form. If you don't fill up the form in that 5 minutes, I'm sorry you won't be able to get the certificate from Google AI. Next up, if you have any questions, any doubts, you can just go ahead and put it in our chat box. We would love to help. We've got our team at the backup. They'll be helping you. And now or on your email, you'll be keep track of all of the things. And make sure you are you know that you're joining a beginner session. So you do not expect any codings today. But in the intermediate section, we might have a physical meetup, like offline meetup in our college. So you can come over there and we'll be having intermediate session, which contains some codings. And I'm sorry for the background noises, which contains some coding stuff. And we'll be working on TensorFlow in the intermediate session. But in the beginner session, we'll be giving a high level overview about the machine learning, all the applications of machine learning, how you can get started with it. Yeah, it will be a Google Forms. And how you can get started with it? Nikhil will share his experience about machine learning, and his all experience will be helpful for you guys. So let me give you the time to Nikhil now. Nikhil will take over, and he'll be telling you his experience about machine learning. Nikhil, over to you. So let me give you the time to Nikhil now. Nikhil will take over. Hi, Nikhil. You're live now. You can go ahead.
All right. All right. Hi, guys. It's good to have you all here and see you all being enthusiastic about the new technology. And I think there's a lack. So, real quick, can you all say hi to me in the chat so that I know that you all can hear me, or if there's an audible problem that you're facing? Just real quick. Just post it on the chat that you're able to hear me and you're good with it.
We are good to go, Nikhil. We are getting high.
All right. I see a lot of highs. All right. All right. Great. So let me start with a brief introduction of what I've been doing so far in machine learning and where I came from towards machine learning. All right. So Namrashi, Sesh all said, Simran, Utkarsh, all right. Ocean Blue, it's audible. All right, perfect. It's good to see all you guys. So being enthusiastic about machine learning. So real quick, I did my bachelor's in machine learning, did my bachelor's in mechanical engineering, and then I worked at Indian Institute of Science, which is in Bangalore, as a junior research fellow at Biomechanics Laboratory. So it was quite a shift from mechanical engineering to biology, and the interest drove me to that place. And I worked there for, let's say, about, I think I would say 1 year. And then during the point in time, I published a paper. I co-authored a paper in Royal Society of Chemistry, and that got published in the Advances Journal. And we're really happy about it. And then I moved on to a startup which was into financial technologies. And I worked there into products for about, let's say, 2.5 years. And that's where I got the opportunity to start coding and working on Python. And we did a bit of OCR over there, optical character. Sorry, what? Yeah. All right. I'm speaking too fast. Okay. So that's yeah. I tend to do that. I apologize for that. So I was working there into products into financial technologies, and that's where I learned Python. And then I got exposed to some OCR, optical character recognition APIs that we're trying to integrate into our products. And I got to know about recommender systems and machine learning and all the cool stuff that you guys are here to learn today. And I was really excited about it. And I think it's from 4 years, and I applied for a master's and decided it was a good time to go for master's in computer science. And my specialization, so University of Texas at Dallas offers quite a few specializations. One of those specializations is data science and intelligence systems, and I'm currently enrolled on that track. So I get to study subjects like natural language processing, artificial intelligence, machine learning, statistical AI, and all those cool stuff that you hear around. And it's been quite exciting. During the point in time at UTD, Dallas, I've got the opportunity to also work at Texas Biomedical Device Center. I'm a graduate research assistant there. We essentially work on neuroscience, neurogenetics problems and use machine learning to try to solve those problems. Now, I'll also be showcasing you what problems we have approached in neuroscience at our laboratory, and I have the presentation, and I hope you will all like it. So, so far so good. Does it make sense? All right, so I see a couple of comments here. I'm interested in data science. I like machine learning. So let's start with what is the difference between machine learning and data science. One of the misnomers that's floating all around the place in industry. You see that quite often. The difference between machine learning and data science is machine learning is more of a research, and you get to study a lot of algorithm. And unlike data science, which is more on the industry part of it, and most of the application is in healthcare and financial domains. And in specifically in data science, we're not at all involved in how the algorithm works, the computational capabilities of those algorithms, and all those stuff. So it's purely based on if you're really interested into I would say industry, go for a data science. And if you're really interested into finding a job at, let's say, Facebook research, I would say go for machine learning. That's the distinction. I mean, because Facebook, okay, so what is deep learning? All right, pretty interesting. So machine learning is this broad scope of problems. Anything that's being automated by machine is called machine learning. And excuse me, and deep learning is a part of subcategory of machine learning which got famous really recently, specifically by Jeffrey Hinton, his backpropagation algorithm. And I would say deep learning is when you have a lot of neurons on steroids. That's how I would describe it. So you take tons of perceptrons, the logistic regression units, you all put them into hundreds and thousands of units and layers, and you just bombard it with a GPU, a high processing unit, and that's deep learning for you. I hope I answered that question. I'm interested in hacking, and I should check my internet connection. What about AI? Okay, so AI,
Ayush,
artificial intelligence is how would you categorize NPL? I think you meant NLP. Okay, artificial intelligence is more of a theoretical subject, I would say, because I assure you none of the new algorithms that have been employed by the automated car, like Tesla or any other, Apple as a matter of fact, they're not using AI. They are all using ensemble methods, which is a bunch of models fit into together, and that's your machine learning or deep learning essentially. None of them are using AI. So AI is this holistic approach or a bird eye view of a problem of solving it with any intelligent system. A Turing machine, as a matter of fact, is I would say an artificial intelligence system. Okay, I should speak slowly. Yeah. So, and how we would actually categorize natural language processing is you try to solve the problems with deep learning, but they are more into textual categorization, not exactly into numerical data. But once you try to solve the textual data with deep learning, like recurrent neural networks and all those cool parts of modeling, then you have natural language processing. So you try to process textual data, and it is such a big deal because the neural networks, as you all might know, only take numerical inputs. They don't take textual inputs. So we use something called we use something called word embedding, and you might have heard of new word embedding techniques like word to vec or glow. These are really interesting techniques. And so this brings me to another point. If you're really interested into machine learning, you should definitely look into, there's a book called Deep Learning. Let me just pull it out. So it's a book called Deep Learning by Francis Scholet. He's the guy who invented Keras, as you might all know. It's a library just like scikit-learn, Keras, and that is how the book kind of looks, and it's really amazing. Deep Learning with Python with Francis Scholet, and you should all look at it if you're really interested into natural language processing. What is the scope of AI in future? I guess that's why we are here, and that's how you guys all will decide it. But I strongly feel uh, that artificial intelligence and machine learning have a really good scope in healthcare domain at this point in time. Because what I'm looking at is most of the things have been in financial sector have been saturated, but not so much in healthcare domain. So healthcare is a big yes. Any courses or book on NLP and ML? Yeah. So this brings me to the point. Most of the courses that you see these days are only limited to academia or theoretical on machine learning. So what you would really want to do is you want to go over for courses which will help you in getting jobs in the market. So Google has come up with something called data engineering, and it's a bunch of like say 6 or 7 courses, and they are all free of cost if you apply for financial aid and you're a student. So not a lot of students know about it. Go for those courses called Google Data Engineering Certification. It'll take you about 6 to 7 months on it, and not a lot of people do have it. So in US, if someone has that certificate, people hire him like a hot cake, and it will break your sweat, but it'll be really good. How it can help healthcare domain. Okay, so in healthcare, and there's one more question. Can you brief about data science scope in future? Okay, with certificate, let me just write it down real quick over here. Google data engineering. All right. What is the scope of cybersecurity? Yeah. Yeah, Ayush. I'll do that. So Ayush would be. I'll send all these links to Ayush, and he'll share with you later after the workshop. What is the scope of cybersecurity? What is the scope of ML? So cybersecurity is really interesting to see how it's shaping up right now. A lot of courses, especially in Carnegie Mellon and Stanford as well, and our university as well. And these courses have been titled as machine learning in cybersecurity. And one of my few friends have also been working on this problem. It's really emerging really well. What is really happening is you have these huge tons of log data from your servers. And let's say a server is, hosting 50 applications. And let's say someone and there are tons of, if it's a hostile attack, if it's a hack, or at the other hand, if you want to see which application has been lagging behind, right? So you get this tons of data, and some of this data is textual and some of this data is floating at the same time. And you integrate both of them together, and you try to predict and solve these problems, which is if you want to predict a hostile attack, or if you want to see if some application is lagging behind, or if you want to find out anomalies as well. Let's say some of the users or applications didn't get a proper ping or response. So you are seeing all these interesting things in cybersecurity as well. Scope in game developer. I think game developer, yeah. I forgot the name of the company which just got hired by Sony, but it's into game development and it's purely into machine learning. There's tons of scope in machine learning in game developing. That's something best you can place your best bet on. Best reinforcing learning algorithm. I think we studied Q learning and it was decent enough and it was smart enough Q learning algorithm. The reason for that is it's not that heavy on deployment on cloud services, and it performs really well. I think AlphaGo is a modification of Q learning, how it's being implemented by Google. making some encryption that can be used for making password data security. I don't think so. I really don't think so. Machine learning could be used for data security in password. And one of the reasons for that is you want to know what your system is doing when it comes to sensitive topics like passwords and data security, because in case of an attack, you want to realize where the attack has come from. But such is the nature of neural networks that neural networks are essentially black box. What goes inside of them is something that you know, but what comes outside of that is something that you know. But what really happens in the middle is something really interesting, and then you don't really know what's happening really inside. So, can encryption also use NLP? I'm afraid not so much. Natural language processing is mostly used in I would say machine translations system and auto-generated systems, as you would see in many Google applications that are coming across these days. So far so good. Do you guys want me to speak about something else that you guys are interested? Just make sure to comment on over here. If not, I would rightly jump into my presentation. Okay. Okay, so I think I should have the presentation. Right. So your entire screen. Okay. Okay, perfect. I'll go ahead with the screen sharing now. Let me just read. Okay, so this is my project, and I just saw a question here. What is neural networks? I'm going to explain it to you while explaining the whole presentation. And so this is our lab presentation. Make sure that you don't take screenshots, and if you do, even if you do, don't share it because it's sensitive data. I'm not. Okay. Just. I think I'm presenting right now. Is it? Right. Right. All right. Perfect. So this is a project that we did in our laboratory, and we've been working on it since I think past 10 months. And this is at Texas Biomedical Device Center. And I'll request all of you to, even if you take a screenshot, don't share it with someone because this is intellectual property right, and this is licensed LLC under US rights. So make sure that you respect the sensitivity of the data. Now, the title of the paper is an approach for human activity recognition using LSTM. So what we essentially do is you would have these fit me bands on your hands, right? Now just imagine for a moment if you use these fit me bands to categorize if you're running and if you're sleeping or if you're walking or if you're sitting, right? You could do that, right? Because it essentially has some gyroscope, the 3-axial gyroscope, magnetometer, the accelerometer, the velocity meter, and all these sensory systems. And you can take those systems and try to classify different movements of your body, your limbic body. At the same time, if you take this system and you try to categorize how good of a movement it is for a stroke patient who is in rehabilitation, right? So you have someone with a stroke impairment and his hands have stopped moving for a certain point in time. And based on how good of a movement it is, you try to give him an electric impulse. That electric impulse is directly through something, I would say, yeah, over here. So this electric impulse is planted in your vagus nerve that's sitting right under your neck, and that impulse goes directly into your brain. So this is essentially the problem that we're trying to solve. And The motivating example from the problem actually came that whenever someone goes through a neurodegenerative disease, one of the challenges that they face is how do they learn essentially. And as Jim Quick says, he's a really good guru for learning new technologies. And if you just look at it, you'll really love his work actually. So just a sec. Okay, so what we're trying to do is there are unlimited possibilities of vagus nerve stimulation, and you see all of these solvents to these problems. Like you can cure depression, you can cure hearing loss, you can work on PTSD, and that's what we do in our labs. And just a sec. Right. So, so when I was working on this project, and I really wanted to use recurrent neural network. So there are quite a things that really helped me. Let me just really quickly show you those things that might really help you. The courses that might help you on Coursera working on this problem. Yeah, this one. This is one of my favorite courses on Coursera. It's called Sequence Models. If you wanna learn anything about recurrent neural network and its application, go with Coursera Sequence Modeling. It's one of the finest courses, and there's a trick for this. As most of you would know, just apply for financial aid over here and wait for 15 days. Don't really pay for the whole thing. There are quite other courses as well. So let me just really go to some courses that I really liked. Active. Right. These were the two courses that I was speaking with you earlier. One is the Google Cloud Platform Big Data and Machine Learning Fundamentals. This course is stretched for 3 weeks and will give you good application of how to use TensorFlow and Google Cloud Platform and integrate with different applications. Another course is Serverless Machine Learning with TensorFlow on Google Cloud Platform. As most of you would know, TensorFlow 2.0 just launched, and it's so much better. It's as good as Keras, and this is one of the courses you should definitely look forward to doing too. Apart from that, there is something called Google Data Engineering Certificate. This one. This is an amazing course. I mean, you should all certainly look forward in doing this Google Cloud, and it takes about 6 or 7 months of doing it, and it's one of the best courses. And also, if you do this course right, you can actually apply for an exam that Google takes, and right over here. So cloudgoogle.com certification data engineer. Just share the link on the chat. You should certainly look at this certification really significantly and seriously if you really want to work as a data engineer or as a machine learning engineer at Amazon or at Facebook, because this is really something that's really interesting. All right, so moving forward, just throw up questions and I'll try to answer them as best as I can. Is machine learning harmful in any case? What do you exactly mean by that? Are you meaning in terms of jobs that will be eating up? If you can elaborate a bit more, I'll be able to answer it a bit more. How does neural network work and how it can be expanded in more neurals? Okay, neural networks kind of work in a fashion that you let me just switch it from stop sharing. All right. All right, perfect. All right, real quick, are you guys all here? things I would really ask you to do is uh, one of the things I'll really ask you to do is go ahead and try a lot of projects on Kaggle. That's forgiven. I mean, just don't stop at a few projects, simple projects like Titanic dataset or Iris dataset, because these are just kitties in the dataset. And I would highly appreciate you if you guys can all go. And there are some paid competitions on Kaggle, and just enroll for them because they really break your sweat and start working on those problems. And that's one of the best ways to learn machine learning, because I think it is one of the extent is to learn theory, and to learn theory from books like Pattern Recognition by Bishop, Tom Mitchell, Machine Learning. And these two books are really good. And if you want to go to the advanced level after a few months or probably a few years, I would highly advise you to go for Ian Goodfellow's Deep Learning Machine Learning book. And it's really amazing. Just go for that. But wait for a few months, spend a lot of time on Tom Mitchell machine learning and pattern recognition by Bishop. Spend a lot of time on these theoretical. And the other extreme to that is spend a lot of time on Kaggle. That's your holy grail. Work it out, break your sweat, and get into good competitions, because a lot of companies and teams, as a matter of fact, as well, they hire directly from Kaggle. And if you do really well on Kaggle, they'll pick up your resume and they'll even try to contact you. I know tons of my friends got hired that way, and it's very real. And try to do it in terms of teams. One of the biggest mistakes that I've done so far is not to try it and work it out as a team, and just try to go on my own at the first and then fail. It's much better, and you learn a lot faster when you go and work around in a team. And all right. Can I provide? Yeah, of course, yeah. So I'll just repeat the books. Just repeat the books for your reference. You guys can just note it out. One of the books is one of the very basic books, and all must read it out. Is Tom Mitchell, TOMMITCHEAL, and it's called Machine Learning. And the other book is Bishop. The author's name is Bishop, BISHOP, and it's called Pattern Recognition. So Pattern Recognition by Bishop and Tom Mitchell, Machine Learning. And I believe Ian Goodfellow also has a book. It's called Deep Learning, I presume, and it's a very famous book. Do read that as well. And if you're really interested in natural language processing, I would say to read this book. And I'm reading it really right now, and it's really amazing. It's called Deep Learning from Francis Schult. So he's the guy who invented Keras. The book name is again Deep Learning by Francis Schult.
Okay, Nikhil, I think it's great to hear from you, and you've told a lot of great things for someone who is like doing some great things in machine learning. You have answered lots of questions from some experts in machine learning, I presume, actually. So this session is about beginners. So let's get on track to the beginner stuff. So Nikhil, this is from your side, and you've done great. All the best, and thank you so much for joining us. So now,
all right, thank you so much for having me, Ayush.
Yeah, definitely. We'll talk on WhatsApp too. All right, Nikhil.
All right. Take care, guys. All the very best.
Okay, Nikhil. So Nikhil will take the lead, and now let's get started with our stuff. The Explore ML program. He was our expert. He did some great things in life, and he will do awesome things in life, and all the best to him. So it's the introduction to machine learning. The program called Explore ML. We'll share you the first link of in the comment section. Let me share you that so that you can put up your email and your entry passcode that you've received on a mail. So we'll be sharing this for like 2 minutes, and the form will be open for 2 minutes. So make sure you fill it before that. Okay, so the link is up. So let's talk about the machine learning. So machine learning is a buzzword right now. Everyone is talking about machine learning. It's like a hype today. So let me give you an introduction to machine learning in a very simple words. So you can just copy the link and put it in your Chrome browser. I guess you can see the link in the chat box. So fill up your entry passcode and email in the link, and it's good to go. We'll share another link at any random time. Okay. So machine, in simple words, teaching the computer how to learn without being explicitly programmed, or without programming the computer how to do that again and again, is what we call machine learning. So let's take an introduction from some videos from Google.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk.
So in this video, we saw how they define the machine learning in a really simple way, I guess. So it says a computer learns from data, and it recognizes the patterns in data and tells us whether any picture is of a dog or a cat. It's a really common example. Classification of two objects. One is dog, one is cat. So what we do in that, we take a machine learning model, we train it with data of lots of pictures of dogs and cats, and tell them which one is dog and which one is cat already. Then we take a new picture which is unidentified by the computer, and we tell the computer to identify whether it is a dog or it is a cat. So we can answer, this is the machine learning. Machine learning is a specific field of AI where system learns to find patterns in example in order to make predictions. Okay, so computer learning how to do any task without being explicitly programmed to do so. So what questions do you have about this? Any questions? If you have any questions, you can just ask me in the comment section. Okay, so the link is going to close soon. Please make sure you fill up the form. So, anything interesting in this? Anything surprising in this? Yeah, it can definitely do. It can definitely solve multiple problems. It's just an example. I guess you take it as an example. So classification can be a multiple task. So it's just an example. Don't take it seriously. Okay. So next up, let's do some hands-on on this really cool game called the Quick Draw game. So here's the link. You can open in this link on your phones. Just type in Google Chrome g.co/quick draw. So we broke down the link. Quick draw. So let's play. It's we try to make this more interactive as we can. So we got a game. What's better than that? So what this game does? It it in this game it asks us to draw anything in 20 seconds. So it asked me to draw a steak in 20 seconds. So let's see if I can do that. It will try to predict whether
I see rainbow.
I am making a
Or
steak
clock.
or not.
Or baseball.
This is how steak.
Or basketball. I see roller coaster. Or wheel. Or harp.
I can make a steak. I haven't seen
I
a
see
steak,
brain.
I guess.
Sorry,
I
I
failed
couldn't
to
guess it.
make the thing that it want, but you see how it is trying to figure out what I have to draw. Let's draw a braid.
I see ocean. Or shoe. Or peanut. Or watermelon. Oh, I know. It's bread.
So it successfully identified it as a bread. So let's see if I can draw rain.
Oh,
I
I
guess
know.
you all are
It's
playing
rain.
this game. It's so great. Great. Let me see. If
I see line. Or fork. Or wristwatch. Oh, I know. It's grapes.
Wow, that's cool. Well, I have a cat.
I see fish. Or tooth. Or foam finger. Oh, I know. It's cat.
Oh, my cat looks so bad. We all drew fish
I
sometimes.
see rainbow. Or bun. Oh, I know. It's fish.
So you see how it recognizes the things that we make, whatever it asks, it's try to guess it, but when it's successfully recognized from the data that it is trained on, it's just great. So if you want to see how this thing works, I guess you've played it. If you haven't, you can go ahead and try. Yeah, the link is not accepting responses. Well, we can open it again for another 5 minutes. It's open now. So I guess you have played the game. It's so fun, and it's an experiment by Google AI. So let's discuss how does the game work, how it recognizes all your drawings, and how could we program that for further inquiry. Okay, so you can go ahead and using this link, and you can see the data behind all the stuff, or all the model behind this model. So if you draw, if it asks you to draw a carrot of ant, so it has more than 115,000 examples drawn by other users, and it tries to learn from these examples. So this is the data behind this. The model is trained on this data. So I guess you can see the lots of examples. Many people have tried it. So it learns from this data. And whenever you draw the thing from your brain, and it tries to matches from the patterns of this data, and it predicts the correct answer sometimes, sometimes not. So this is how this thing works. So you can see if you do it by a rule-based approach, there are basically two types of approaches. First is rule-based, which requires any like mathematical approach or manual approach. Next is machine learning approach. So in a rule-based approach, you can see you first frame the goal of the product. That means you have to identify whether it is a carrot or not. You define its rules. Like designers and engineers develop the flows and logic. So it's like logic is over here. Like what would be if the height is of the object is greater than 10, do X, classify it as carrot or any other thing. If the color is blue, then do Y task. If the number of legs is greater than 2, then do Z. So it's the rule-based approach. We have to define each and every step like in a sequence, step-by-step manner. So this is the rule-based approach. So at the end, we refine the, like, we again and again try to make it more correct until we reach our goals. So this is the rule-based approach. So we can do that rule-based, but it is way more easier in machine learning approach. So we have to frame the goal. We need to next step, we need to train the model. Model is like an uh, algorithm we train using the data. So this is the data over here. We just have to gather more and more data like this. So we are trying to teach computer. This should be the carrot should look like a pyramid with something on top. So we are trying to teach it. So there are lots of examples drawn by human, and if we give a new example, it will try to match the patterns over here, and it will predict correctly as the carrot. So, and we will refine the data. We will add more and more data until we reach our goal. Okay. Some people are asking how long will it be the workshop? So I guess till 7 p.m. And the sheets, the slides are not open source, so I guess you won't get it. I'm sorry about that. Okay. So next, let's do something interactive. So which approach should we use in this? Like alphabetizing a list of song titles. Like if you have a playlist which contains some songs, so if you wanna sort this from A to Z, so I guess which approach should we use? A rule-based approach or machine learning? You can go ahead and type in the comment section. I wish this could be a physical meetup. ML, well, we can do that. Anyone else want to answer this? I guess we can make it two-way interaction. Nobody's interested, I guess. Well, that's fine. We can do this it's basically a rule-based approach. Why? Well, it's just a simple algorithm, sorting algorithm. We see so much. The question is fast. You can try again. Well, there are so much sorting algorithms like merge sort, quick sort. You can use that. That's a rule-based approach. Why use machine learning for that? So we can use machine learning in this. There are fixed number of letters and alphabets. Let me know how can we use machine learning in this in the comment section. Anyone wants to answer that? No one's. What do you think? How can we use like machine learning in alphabetizing a list of song titles? Many have written machine learning, but no one's interested to answer. That's fine. We'll move ahead. We have got another question. Which approach to use while ranking web search result? What do you think? Google's web search result. Like if you search for ice cream recipe, what do you think we can use for that? If you search for Google ice cream recipe, you see a lot of results coming out. So the most appropriate answer is at the top. So it's called the web search ranking. Okay, machine learning. Well, that's a surprise. We can use both the stuff. So when Google started, it uses rule-based approaches, but now it's now going to machine learning approaches in web search results. So that the approach you take would depend on your goals. Basically, that's the whole point. So are you ranking web result based on relevance to my query? Well, we can ask that to Google. If the query was news, you might also want to take into account how recently the article was posted. So if we are searching for any news, we would love to have more and more stuff related to that. we can do both things, rule-based and machine learning. Predicting housing prices based on location. Well, that's I guess everyone knows the answer who are interested in machine learning, who are doing it. What do you think? Which approach should be used for this? And why? The question is also why. Yeah, we got an answer. Regression. So there's no perfect formula for determining how how much a home would cost based on its location. There's no particular rule-based algorithms. So we will use machine learning for that. We will have a lot of data coming over here, and we will try to predict based on some labels of some features like nearest gas station, nearest bus station. Based on some lots of features, we can predict the housing price location based on housing prices based on location. Processing online payments. Anyone would like to answer that? Rule based. Yeah. Right answer. So there's no right or wrong answer. If you have any wrong answer, you can just it doesn't like matter. It's just like check your understanding. So we can use rule-based approach for this processing online payments. It's a simple algorithm of getting a transaction, accepting the checks, and processing the withdrawal or deposit. So it's a simple thing. But we can use machine learning in this, like using fraud detection algorithms, so that if something is like if some unwanted steps are happening in our account or in any transaction, so we can detect it. So machine learning can be used in this, but it's basically a rule-based approach. Classifying an object in a photo. Well, it's a simple classification task. I guess everyone knows this answer is machine learning. So let's recap what we've learned so far. In rule-based approach, we define rules. We prove the improvements come from the algorithms and network. Like if we try again and again, we try to find the bugs and errors. We try to fix that. That's the rule-based approach. Meanwhile, in machine learning, the model learns from patterns in the data. Okay, so it tries to learn the patterns in the data, the machine learning model, and it improves as we add more and more data. So each has its benefits. Everyone has different thinking. So everyone has different advantages. So it's like that. Okay, so any ideas you have in your mind that you can implement while machine learning? Okay, I'm a classic question. Well, let's see another video.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
So you see in the video, we focus on these 5 processes called the machine learning process. So we saw, first of all, we focus on user. We take what are the needs or what is the requirement of the user, or what is the problem that he or she is facing. We try to identify whether it can be solved using machine learning or not. Okay, so with this keeping in mind, we define an objective on how to proceed. For example, predicting which friend user is like to share a photo with, or suggest the user eat in a new city based on a restaurant they have visited in the past. So these are some examples that user can give us, like to make a machine learning model over that. So we define the objective of that. So then we start to collect all the data required for that, so that we can train the model. So the most important part is data. So without data, there's no machine learning. So if we have a good data, we can train a good machine learning model. If we do not have a good data, we don't have a good machine learning model. So the output might misfunction because of bad data. So machine learning models learn from examples. Basically, examples like the data we have. So essentially, if it's very great to find large amount of existing data, so that we can train model like quite effective. Okay. So expert says, first we collect the data, then we clean the data, then we try to explore the data for any missing values or any kind of data pre-processing. Then it tends to a great training in machine learning model. Okay. So you see after training the model, it goes to predict and evaluate. So predicting is like, let's take an example of classification of cat and dog. So it predicts whether the new example is a dog or a cat, and if it is right, in the evaluation phase, if it is right, it marks as right, and if it is wrong, it's try to take that as a feedback but in reinforcement learning, not in this. But it tries to collect more and more data, not the data. We try to collect more and more data to fix the model if there's any misfunctioning in that. So you can see the arrow going back to collect data. Then again, it trains the data, and then it predicts and evaluates. So evaluation is quite important phase. So data, it's great to have large amount of data so that we can train, we can have good training in the model. So I guess you understand. If you don't, that's fine. We'll try to work on that. There's another video.
Let's play a game.
These videos are not open source, so that's why we are seeing it over here.
Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
So you saw how machine learning has some biases in it, like gathering human biases. So if it says if you think of a shoe, you are biased to a particular kind of shoe. So sometimes machine learning model isn't biased that much that humans are. So machine learning models are basically trained on the data we think of. So if someone has a choice of male type of shoe that it shows in the video, and if you try to give it a sandal, or that's what we call heel sandal or heel shoe, then machine learning model would not recognize it as a shoe. So gather and select the so videos. Let's take the key points from the videos. So gather and select only the data that your ML system needs to achieve its goal. The less the data you have in the first place, the less you need to protect. I guess we've missed it.
Let's play.
Sorry about that. We're talking about next. Okay. So you see how humans are prone to trust results from a computer. We assume your technology will also work as designed until it breaks. So once someone describes you to new application of machine learning, what question do you ask them based on this video? Did you get my question? Anyone in the chat wants to answer this? When someone describes to you a new application of machine learning, what question would you ask them based on this video? Yes, I guess you've seen the video, the things that are taught in the video. So what do you think? No response. I see the interaction that you guys are doing. It's so great. So you see, most of the times, machine learning models are biased towards something, just like humans are biased towards something. So I guess we need so to solve that bias and latency, we need more and more data to train the machine learning model. Well, let's see what ML can do. Any ideas you want to implement in ML? Let's see some real great things. It's easy to look at examples of machine learning and see it as magic, but it does not open a lot of it does open a lot of new possibilities for technology. We already considered for certain situations whether ML was necessary. In this section, we discussed what type of problems is best suited for. So just like we did for rule-based approach and machine learning approach, we already did it. Let's open some new possibilities. So most of you are confused what AI is, what ML is, and what deep learning is. So it's like a buzzword. We like use these words in place of each other. But let me tell you, this is the real picture over here. So artificial intelligence is the whole name is defined as a technology which appears to do something smart. So if, for example, let's take an example of artificial intelligence. If you have a microwave oven at your home and you set a timer of 30 seconds and it stops after 30 seconds, this is kind of an example of artificial intelligence. That machine knows it has to stop after 30 seconds. Moreover, it's a rule-based approach, but it's an example of artificial intelligence. This can be anything from program software to deep learning models. So like program software, microwave oven, deep learning model, self-driving cars. So that which mimics human intelligence. So basically, artificial intelligence is when computers are trying to copy human intelligence. So this is what artificial intelligence is. The inner part of the part of artificial intelligence is machine learning. Machine learning is a specific kind of artificial intelligence. But rather than rule-based approach, we swipe out the rule-based approach. The system learns how to do something from examples without being explicitly told to do so. So in machine learning, we try to teach the machine how to learn from patterns of data. So it's like a sub part of artificial intelligence. So deep learning is a specific type of machine learning, which uses technology known as neural networks. So neural networks we'll talk about in intermediate section. So neural network are based on are the ideas taken from humans' brains neurons. So it's a like kind of advanced stuff. We will not talk about that over here. So deep learning is a specific type of machine learning using a technique known as neural networks, which connects multiple models together to solve even more complex type of problems. Deep learning is similar to other machine learning models, learns via examples. It's unique because it connects model to other models in layers. So it's kind of unique from machine learning. What makes it unique? It connects other models to one model to other models in the form of layers in order to handle more complex tasks. So I guess it has cleared all the doubts about these three words and how to use in the right places when you talk to someone or when you speak about the technology of AI, ML, or DL. Okay, so this is the AI has a subpart machine learning has a subpart deep learning. So we'll be sharing another form like after at any random time. Make sure you are taking your concentrated on this. So let's talk about some history of machine learning. that brings us to this very simplified overview of the history of machine learning. So you see three circles. It's a Venn diagram kind of. So you can find more detailed timelines on Wikipedia, but here's the main takeaway. It's just high level overview of history. The key algorithms powering machine learning were formulated even as much as centuries ago. So like machine learning is not new. It has been already discovered like centuries ago, not on computer, but in physical tasks. They come from disciplines like statistics, linear algebra, biology, and physics. So basically, machine learning involves mathematics, statistics, linear algebra, and biology and physics. Everything is consists of. So for the last few decades, sufficiently large amount of data were collected to train models. So as you see, we are in the era of data and machine learning. So machine learning is totally based on data. So in last few years, we got a lot amount of data and high computing power. So that's why we are doing machine learning now, in spite of doing it before. So okay, so sufficient for last few decades, we got sufficiently large amount of data that were collected to train models, but they were low quality and expensive to train few decades ago. So lack of progress and prospects to lead to an AI winter, where ML was considered a waste of time. So when we talk about ML in 90s or 80s, like so it was totally kind of waste of time. I was not there, but it's written in articles that I've read, because there was not high computing power that can process the data of that time, and the data was of quite low quality. So we are doing it now. In the last few decades, the availability of relatively cheap and fast computing powers have enabled the complex calculation across large set of data necessary to train high grade models. So you can see machine learning is a combination of algorithms, technology, and big data. So without data, there is no machine learning. Without algorithms and mathematics, there is no machine learning. And without technology, there is no machine learning. Technology is in the sense of hardwares that we are using, like GPUs and CPU, high computing TPUs. So without this, there is no machine learning. If we talk about in like last few decades, it was not there. So let me. I got a question. I didn't get it. So let me tell you like in a simple way. So machine learning is in the history we do not have, like in the past times we do not have a good amount of data and good computing power. So we use rule based approaches rather than using machine learning. But now we have large amount of data. We have got efficient algorithms and we got high computing power. So we are using machine learning now. Okay, so let me tell you a few applications of machine learning. First is a classification, like classifying whether it's a lion or not, or classifying whether it's a cat or dog. So classification is a common application of machine learning. It's quite common. We see the system determines which class or category an example belongs to. So you can see there's a line over here which says if it's like a blue circle, then it will be something else. If it's a red circle, it's basically classifying using this. Okay. So output can be the output can be a level and a percentage of confidence. So what machine learning does, it tries to predict and in the form of percentage, and there are lots of evaluation processes that we can do. For example, if the classifier was trained to identify whether or not an image was a lion, it might output yes or no. However, if it is more generically an animal classifier, it would output whether it is a lion or tiger. So you see, classifying between two objects or multiple objects is what classification is. Classification system depends on the threshold set by humans. So If we say we got this image, we define some thresholds or some rules that allows machine to classify whether it's a loin or not. So the features of loin would be way more hair over the head. The nose is quite outside of the body, and it's quite big in height, and all the features. These are just examples. So these thresholds are set by humans who make the model. So, or let's take another example of email, spamming email. So whether an email is spam or not. So it's like that. So we define the rules. If it contains lots of spelling mistakes, then the model would consider it as an spam. If it's quite right, then it's not a spam. So these are two examples of classification tasks. Next is regression. So regression is regression system outputs number of examples. Like for example, let's take an example of previous example, predicting housing prices based on location. So we see lots of features. We take it as x and y. So for any value of x, what would be the value of y? It's like that. So regression outputs a number. For example, how long it will take to drive from point A to point B, or the likelihood that someone clicks an ad or not. These are some high-level examples. Some easy example would be to predicting housing prices, or there's a competition on Kaggle, Titanic survival prediction. So on the basis of some features like male or female genders, what would be the class, first class, second class, third class on Titanic, we try to identify whether that passenger survived or not. So it's like it's a regression task. Next is clustering. Clustering is when we got another example of machine learning is how to define closely related items to one another. So if we are not provided with any labels, we try to give them by seeing the data with similar properties. So in the slide, the data of hand-drawn images is moved into clusters of same numbers, like ones. These are the type of ones. So you see, everyone has a different style of drawing a one, but we classify it as one. Everyone has different handwritings. So you see two. So we try to separate the data of one and two into clusters. So this is another example of this is the example of clustering. Another example would be separating the customers on particular shop. Like someone in a shopping center, someone wants different in a mega mart. We got variety of products. So each product has different set of customers. So if someone wants any face cream, they will separate the customer, and if someone wants any clothing stuff, they will have separate customers. So it's like clustering the similar property data into clusters. Yeah. Next is sequence prediction. In order to assist users, it can be helpful to predict what they might do next. So based on some sequences, we try to predict what will predict what would be the next move of any person or user. So this is called sequence prediction. So we try the machine learning model try to predict the next move using the previous sequences. This could be a prediction on the next keyboard key, like when you use phone. So this is an example of Gboard. So you can see it's making patterns, and it tries to identify what would be the next move, and it gives the suggestion of that word on your phone keyboard. So this could be used to propose a spelling correction, suggest replies to a text message. There are lots of examples. Other examples of sequence prediction could include the next video a user might want to watch, like on YouTube. Based on your previous history, it tries to it gives a recommendation of what what you want to see next. Okay, so you can this is a sequence prediction. Next is style transfer. Style transfer is, or style transfer generation involves training a model on one set of data and then applying that model to something completely different. I guess you got it. So we're trying, the machine learning tries to train data on one model of one set of data and then applying that model to something completely different. So the most common example of style transfer would be like text to speech, or it could be seen in this example, remarking photographs to look like another piece of art. Just why it's an example, it's not machine learning task. So we are trying to uh, make gathering all the uh, we are trying to add up all of both the pictures and make our new piece of art. So this is the real world example, but in machine learning we can we can take the example of text to speech production, translating from one language to another. This is the style transfer task. Now that you've seen a few examples of machine learning, let's go through some other examples. You tell me which type of machine learning best describes it. I say best because some problems can be solved by multiple approaches to machine learning. So next up, we'll be having the same quiz, same check your understanding kind of quiz. So we will have another examples in the chat box. You can just go ahead and type your answer. There's no right or wrong stuff. It doesn't matter. So we will share another form in like 5 minutes. We will check if everyone has filled both the forms. We will circulate the link to the to how to get a certificate. Okay, it's in 5 or 10 minutes. Yeah. So which type of machine learning should we use in this problem? Recommending what someone will download based on previous purchases. What do you think? Which type of machine learning should we use? Classification, clustering, regression, sequence prediction, style transfer. Please answer. We will share the, we will reopen if you want in the last, but please focus on the presentation. I will appreciate that. Clustering, sequence, maybe style transfer. Recommending what someone will download. The answer to this is, yeah, sequence prediction. That's great. So don't worry if you have wrong answer. That's totally fine. We have lot more questions. So why sequence prediction? Well, you see, while all examples of machine learning involves uh, sequence prediction, okay, recommendation what someone will download. Just like we saw in the Gboard example, what would be the next move of the user by suggesting it in the keyboard, just like that case, or what a user wants to see on YouTube after watching some videos. So it's an example of sequence prediction. Next, labeling email as a spam or not spam. What would be the answer to that? Whether an email is spam or not spam. It's an easy one. Come on. Which type of machine learning should we use for that? Right? Classification. That's nice. So you got it right. Classification is the answer to that. So based on some features, we try to classify the email as spam or not spam. Next, which type of machine learning should we use for that? Identifying trends amongst a group of people who have bought a new music release. So what do you think? Classification, clustering, regression, sequence prediction, style transfer. So we are trying to group up the people over here. Clustering, okay. We got it, right? So it's clustering. Yeah, you got it right. It's not style transfer, it's actually clustering. So we are trying to group up the people into clusters of similar trends. Okay. Next, captioning a video. Like captioning is for subtitles. Captioning a video. What type of machine learning should we use for that? It's like uh, from voice to text. I guess it's a hint. Yeah. Someone says it's style transfer. Yeah, you got it right. Style transfer is the correct answer. Well, I guess you're learning some stuff. If I'm audible and if you can see the video, you can just write in comment or chat box. Am I audible? Is it clear? All right, that's great. Sorry about the technical fault. So, captioning a video, some of you were writing style transfer. That's great, I got lots of yes. So, style transfer, yeah. So, converting one thing to another is style transfer. Next type of machine learning should we use in this? Determining workout activity based on phone movement. Like, what do you think? It's so easy. Classification, clustering, regression, sequence prediction, style transfer. What do you think? Sequence. Well, there can be multiple answers. I'm sorry, it's a classification task. Well, it could be possible we can determine it without machine learning, but it's classification how whether someone is doing push-ups, uh, whether someone is doing sit-ups, so it is going up or down. So we're classifying it as up or down. Okay. Oh, we got 3 answers for the same. Okay. So classification is the answer for that. The goal is to output discrete levels. Discrete means either 0 or 1. So such as whether a person is walking, whether he's running, whether he's jumping, which makes task a good fit for classification. So we're classifying it based on phone movement. Okay. Next is predicting the strength of password. What do you think? What would be the answer for that? Strength of a password, whether the password is weak, strong, or sorry for the hint. What would be the answer for that? Someone says regression. Regression. Okay. Can you tell me why is it a regression task? Which says clustering. Can you please tell me, just writing few points, why is it a regression? Okay, so I got the answer, I guess. So it's not just classification, it's also regression task. So congratulations, you got it right. So how is it a classification task? Whether it is a strong password or it is a weak password or somewhat in between. So we can classify it as strong or weak. How is it a regression task? So whether your password is 50% stronger, if we add numbers in that, like you might want to add any special symbol, you might want to add any number. So based on that, if your password is 50% stronger, your password is like that. I guess you got the idea about it. So it's both. Identifying famous landmarks in a photo. It's easy. You can answer that. Which type of machine learning should we use in this? Okay, so we got the answer. It's a simple classification task. Identify whether what type of landmark is that. Next is suggesting spelling corrections. We are about to end. Suggesting spelling correction. I have already said that in an example of type of machine learning. What do you think? Which type of suggesting spelling corrections? Sequence prediction, classification. Oh my god. So the answer to this is not sequence prediction, it's actually clustering. So I've already given the example in clustering with collecting like handwritten digits. So what same type of handwritten digits are kind of using that. So another example is spelling correction. So clustering is we are trying to collect same type of spellings in like similar type of spellings, like for example, let me think of an example for that. I can't think of an example for that. There's same so clustering is useful approach for this problem because misspelled words tend to be closer to intended words. So some spelling corrections, like you write how the spelling of how is HOW, and you wrote HO only. So it will try to gather that type of words like HOW, HOE, HO only. So it is a useful approach for this problem. If we can get misspelled word tend to be closer to the intended words. Also, if another word entirely was intended, such as I've got an example, advocate in English, and there's an advocate in France without the D, French. So we can have similar type of words over here clustered together. Okay, so another example is avocado. It's a type of fruit, and which is in English, and there's a word in French which is avocat. So these two types of these are kind of similar words clustered together. So it is possible to build spelling checker using traditional approach, but they would be complex, of lower quality, and need to be adopted to fit new words and slangs. Slang language. Oh my god. What do you think? What type of approach should be used by them in this predicting the quality score for an advertisement? Predicting the quality score. It's an easy one. Regression. We got an answer. Regression. That's nice. So regression. It's a type of regression problem. So the output of the machine learning system is continuous numerical value. So we are trying to predict out similar. We're trying to predict out the scores based on. So let's take example. For any particular value of x, we are trying to predict y. So here's the same case over here in predicting the quality score for an advertisement. The output of the machine learning system is a continuous numerical score, such as 3 out of 10 or 97.2%. The scores would be passed based on numerous features. So the score would be dependent on numerous features. So it's a regression task. We got a few more questions and then we are about to wrap up. We'll talk about all the stuff in the end, the forms and things. So, oh, I'm sorry, I missed the question. Estimating the arrival time of waste, we already got the answer. It's a regression time. It's a regression type of machine learning. So we are the output of the system is numerical values. So numeric data. When we got numeric data as an output, it's a type of regression, obviously. Translating between two languages, it's simple. It's style transfer from one language to another. One type of model trained to another. So let's quickly recap what we have learned today. We are about to wrap up. We will tell you how to get the form, and we are sending another link to the. We are sending you the another RSVP form link, which is the second form. The link is on the way. So let's review what we've learned. Meanwhile, my friend is sending the link. Okay. So what is machine learning? We already know what machine learning is. Teaching the computer how to learn is what machine learning is, without being explicitly programmed. So I guess you might have got clear understanding what is machine learning. So here's the second link. You can see the second link in the chat box. Fill it up. You have 5 to 10 minutes. I guess for those who have not filled the first link, we will try to send it. We will try to solve their problems too. Meanwhile, filling up the form. Let's review again. What is machine learning? Teaching the computer how to learn. Performing any task by computer without being explicitly programmed. So ML versus rule-based approach, we saw lots of examples of that, like sorting the list of songs and examples like that, and machine learning tasks like classification and all this stuff. Ideas to implement, we saw ideas, we asked you, but you didn't say. So ideas might be making a face detection system or self-driving cars. So this can be done using the branch of machine learning called the deep learning. There are many more ideas. Next up is AI versus ML versus deep learning. So we presented you a diagram. Like deep learning is a part of machine learning. Machine learning is a part of artificial intelligence. Next is history of ML. We saw why didn't we use machine learning back in 90s or 80s due to lack of data and computer processing power. Another is types of machine learning. What are the types of machine learning? Classification, clustering, regression, sequence prediction, style transfer. We saw lots of examples on that, and you also answered those things. So this is the Explore ML session of first tutorial, first thing of Explore ML session. Next session on the beginner track would be tomorrow. That would be not more than half an hour. We try to cover it in only 30 minutes. That's not longer than that. We will try to come up with the topics of some advanced machine learning, like what are neural networks, how can you use them, how to learn them. And in the intermediate session, that would not be online as per our plans. This session is intended to be online because of some venue problems and the examination stuff. So the intermediate session would be totally offline. We will have a guest maybe and machine learning expert for who is working in industry. We will try to contact him whether he will come or not. Next up, intermediate session would be hands-on session. So we would love to have you on board, and we will work on TensorFlow. So and that would have some prerequisites, like you should know Python, and before that we will try to teach Python in developer student clubs in college. So this session was online because of some constraints that we could not follow. So where it will be conducted, in Gwalior in Rustomji Institute of Technology, or we will tell you the venue on your mail whenever we have it. Next, if you want to be a part of the team, we will have recruitment soon. If you want to see the events, you can go ahead. You can go ahead to DSC RJIT.co. So this is our official website, dscrjit.co. So if you want to be a speaker over here in our events, this community is open for all. You can send us a proposal. If you want to take part in events, here are the events. We are having a Flutter Interact viewing party on 19th January in Gwalior at Sorted Square co-working space. Okay, we will update you about it. We will have an expert from Flutter Gwalior, and we did a few events, and we are going to do awesome things. So make sure you keep updated on dscrjit.co and on our social medias. So this was the beginner session. Tomorrow's session would be maybe at 7 o'clock. We will send you an email with different RSVP. We would love your feedback. These presentations were presented by Google AI. So these are not made by me, and these are not shareable, so we can't share you. So make sure you give us feedback. We will roll out the feedback forms after tomorrow's session, and this is the wrap up. And I guess those who have not filled the RSVP, both the RSVP form, might not get certificate for beginner session. So if you join late, we can give you 2-minute windows to fill up both the forms. So we can, there's 2 more minutes. You can check whether you filled both the forms or not. It's very important to fill both the forms. Otherwise, we are not, you cannot claim us if you don't get the certificate. So make sure you fill both the forms. We'll share links how to get the certificate on your emails, on your respected emails. So don't worry, you are in the right hand. And make sure you give feedback on the feedback form we will share after tomorrow. So make sure you come again tomorrow for half an hour. That would be not more than half an hour session. We won't take a lot of time. So it will start from 7 p.m. We will send you another mail to 7:30 p.m. Not more than that. We won't take even 5 minutes extra. Okay, so 7:30 p.m. See you tomorrow, and make sure you fill both the forms. Let me send you both the links again. They are open for 5 minutes. Make sure you fill the form. It's very important. This is the first form. This is the second form. They are open for just for another 5 minutes. At 6:50, we will close both the forms. Can you come, please? Can you please come early? Like not 7 p.m. How about 6:30 p.m.? Not earlier than that. Make sure you fill both the forms. You have 2 more minutes. 6:30 would be great. We'll share an update tonight or tomorrow morning. Not more than half an hour. We won't take more time tomorrow. Just half an hour. It was a long session. We talked quite advanced stuff too from our expert and from maybe me. So it depends on your feedback. How great this session was. Make sure you feedback so that we can improve in our next session. And to join the team on DSC, make sure you follow the website and all the social media. We want to thank you for Parag Gaikwad. He's saying anytime. So we are about to close the link. We got another minute and the session will be wrapped up. Thank you so much for joining us. We really appreciate your time. Although it took quite more than we expected, we were about to wrap at 6:30 only, but the presentations were long. You can give the feedback to Google AI team too. We will share the form. So make sure you feedback on their side too, because these presentations are not made by us. The curriculum was totally made by Google AI, so they require feedback more than us. So we were trained to present it by Googlers. Let me know how many of you are from RJIT. Please type in the chat RJIT. And how many of you are from ITM? Please type in the chat ITM. One more thing, if keep writing your college name. And one more thing, if you want the sessions in Hindi too, we would appreciate that to be written in a feedback form, because we are trained to do that in English, so we are doing the same. It's really appreciated if you please fill up both the forms. We're about to close it. 6:50, the forms will be closed. Thank you so much for joining. The forms are closed. We really appreciate your time. Please do join us again tomorrow at 6:50 or 6:30 or 7 o'clock. We'll update you on email, and also we'll share if you have filled both the forms with your commuter's registration entry passcode. You will definitely get a certificate from Google AI team. And thank you so much for your time. That's it. Thinking on leave, Ayush Sharma, lead and developer student clubs.